All right, welcome everyone. You guys just did a little bit of a simulation with me in class to learn a little bit more about the greenhouse effect. Now we're going to put some of that with our vocabulary that we use to describe this phenomenon. I know you guys have learned about the greenhouse effect before, but we're going to go a little bit deeper than you might have in previous classes. Please take notes in your student handout. Suggested headings have been provided there. So these are the key points that we're going to go through today and that I'll reiterate throughout the lecture. The first is that our principal greenhouse gases, the ones that we think about often when we talk about the greenhouse effect and about air pollution, are CO2, methane, water vapor, nitrous oxide, and chlorofluorocarbons, or CFCs. The second is that the greenhouse effect occurs in the troposphere, which is below the ozone layer. So we often sort of think about this greenhouse effect as occurring in the ozone layer. It is super important to remember that it occurs below the ozone layer. The third is that a minimal amount of greenhouse gases are necessary to re-radiate or reflect heat, and that this phenomenon, which is known as the greenhouse effect, results in the surface temperatures that are necessary for life on Earth to exist. Finally, global warming potential, which we will talk about a little bit at the end, is the heat absorbed by any greenhouse gas in the atmosphere and is measured with carbon dioxide as the baseline. So we'll go through these one by one. So your first heading in your notes is a table that looks exactly like this. I'd recommend taking notes on the principal greenhouse gases and the major sources where they come from. To go through this really quickly, we have carbon dioxide, which comes, we've talked about a lot, from electricity, from transportation, from deforestation, and from fossil fuel production and emissions. Methane is often something we think about when we talk about natural gas, petroleum systems, and agriculture. Methane is often something we think about as a gas being released from the gas pump. You guys remember we talked about vapor recovery nozzles yesterday. Some of that is used to recover methane. Water vapor, I put it on here. It is an insignificant greenhouse gas. It does not contribute much to the greenhouse effect or to global warming as a whole. It is found in the water cycle, which we've talked about a lot through evaporation and then condensation of water into vapor. Nitrous oxide, we often think about that when it comes to fertilizer and soil management, other agricultural practices. And then lastly, chlorofluorocarbons, or CFCs, are found in refrigerants and aerosol sprays. So all of these greenhouse gases and their sources are important for you to know for the AP. So what is the greenhouse effect? Hopefully this is some review from your past classes. So the greenhouse effect is this process that occurs when greenhouse gases in Earth's troposphere absorb and re-radiate heat in the form of infrared radiation. And what we're going to think about is that the greenhouse effect is actually super necessary, as we saw in the simulation, for life on Earth to exist. So you guys can see the sun is giving off heat in the form of sunlight. That energy that comes from sunlight is mostly absorbed. So most of the heat that comes from the sun, that thermal energy, is absorbed into our terrestrial biomes. Most of it is absorbed on Earth. However, a decent amount of that sunlight, a decent amount of that energy is reflected back. So some of it's absorbed, some of it is reflected back. If we did not have greenhouse gases that could trap these infrared radiations, and re-release them and re-radiate them, our surface temperatures would be much, much too cold. So we actually need greenhouse gases in order to sustain life, in order to have the surface temperatures necessary to sustain life. So once again, our sunlight is giving off heat. That most of that heat energy is absorbed, but some of it is reflected back into the atmosphere. But our greenhouse gases can trap those reflected sunlight and that reflected energy in the form of infrared radiation and can re-release it back downward into terrestrial spaces. So again, super necessary to remember that the greenhouse effect is something that we do need to make the Earth a habitable planet. Although we're going to talk about how we have too many greenhouse gases in our troposphere later on in the unit. So the greenhouse effect again occurs in the troposphere. This is the part of the atmosphere closest to Earth. So you guys can see it is the lowest level of the atmosphere. And really, really important to note that the greenhouse effect does not take place in the ozone. So instead of taking place in the ozone, it takes place in the troposphere, which is part of the atmosphere closest to Earth. Last thing really important to note that the AP often talks about is global warming potential. This is the heat absorbed by any greenhouse gas in the atmosphere, basically how much a particular greenhouse gas contributes to global warming. It's measured with CO2 as the baseline. So this vast majority of our greenhouse gas is CO2, but other greenhouse gases have a bit more global warming potential. Some of them have significantly higher global warming potential than CO2. So if CO2 is measured at 1, you can see methane, CH4 is 23, all the way up to dinitrogen oxide, which is 296, and then you have some greenhouse gases that are at 22,000. So this is just a way for us to quantitatively measure how greenhouse gases contribute to global warming. So again, greenhouse effect, our greenhouse gases are re-radiating and absorbing heat in the form of infrared radiation. It's necessary for life on Earth to exist, and it occurs in the troposphere. All right, next we'll move into some checks for understanding and then some free response practice.